So what if we wanted to evaluate compositions? On this one we have the same three functions. We want to evaluate them at specific numbers. So we're trying to find f of g of 5. Well, the first thing you want to do is find g of 5. That means substitute in 5 wherever there's an x in g. So we're going to have 2 times 5, sometimes it's better to use parentheses, and minus 1. So that's f of 10 minus 1, or f of 9. Well, now that you have this, you take the 9 and substitute it into f. So that would be the square root of 9, which is 3. So f of g of 5 is equal to 3. Okay, how about g of f of 5? Do you think it would be the same? Well, f of 5 is the square root of 5. And if you substitute that into g, you get 2 square root of 5 minus 1. So they're not the same. So when you do compositions, it really does matter the direction the composition is written. So here's a couple. Let's try these. Number 3, we're doing a triple composition. So we have h of g of f of 9. So we have h of g of, what is f of 9? F of 9 is the square root of 9. So we have h of g of 3. And what is g of 3? G of 3 means 2 times 3 minus 1. So that's h of 6 minus 1 is 5. And what is h of 5? That is 5 squared, which is 25. So h of g of f of 9 is equal to 25. Cool. Okay, so let's start number 4. Before we begin a problem like this is called a composition. Before we begin a problem like this, we need to come up with the domain of the composition. And to do that, you first need to find the domain of the input function. If you wrote this in that form that I said, I like f of g of x, the one that's inside is your input function. So we need to know the domain of g. That's going to be this one. So it's all real numbers. After we get the domain, oh sorry, that's the range. The domain of that particular function is still all real numbers, because it is a linear function. Since we know the domain of this particular function, now we find the composition, and once we get the composition, we find the domain of that one. And then we find the intersection of those two. So right now, let's do the composition. We're going to put g inside f. Well, f is the square root of x. Remember, you remove the x and you put the function g in its place. So we have 2x minus 1. Well, what is the domain of this particular function? Remember, it's a square root. And square roots can't have a negative radicand. It can't be negative underneath. So you say 2x minus 1 must be greater than or equal to 0. Add 1 to both sides. So 2x must be greater than or equal to 1. Divide both sides by 2, so x is greater than or equal to 1/2. And if you were to write this in interval notation, it would be 1/2, including 1/2, to infinity. Now what you want to do is find the intersection of this domain and this domain. Well, this one is everything. It's negative infinity to infinity. This one is only 1/2 to infinity. Their intersection is what they have in common, which is going to end up being this 1/2 to infinity. So the domain of this composition is 1/2 to infinity. try a couple more. So this time we want to find g of f. That's g of f of x. So we need to find the domain of f, which is here. That's going to be 0 to infinity. And then we find the composition. This time we put f inside g. So what I'm going to do is write down g without the x. And in the place of that x, I'm going to put the function f. But f happens to be the square root of x. So we get 2 square roots of x minus 1. This would be our function g of f. Now we need to get the domain of g of f. Well, the domain in this particular case is strictly greater than or equal to 0 because of the square root. So just looking at this part of the problem, the domain is 0 to infinity. We need to find the intersection of this domain and this domain. Well, they're exactly the same. So the domain of this function is 0 to infinity. How about this last one, h of g? This time we want to find the domain of g. The domain of g is going to be all real numbers. I don't know why these won't stay. That's weird. Okay, so now we're going to find the actual composition. We're going to put g inside h. So let's write down h, that's something squared. And in its place, we're going to put the 2x minus 1. 2x minus 1 all squared means 2x minus 1 times 2x minus 1. That means 4x squared minus 2x plus 1. So we get 4x squared minus 4x plus 1. This is the composition. And what is the domain of just this? The domain of just that is everything, right? There are no fractions, there are no square roots. If you take this domain and this domain and find their intersection, what is the domain of the composition? Well, they're exactly the same. So this is the domain of the intersection as well. On the next page, we have a couple for you to try. So maybe pause the video, work them, and then restart it and see if you get the same thing. So for the first one, we want to find h of j of 5. We don't need a domain for this particular problem. h of j of 5. So we're going to find j of 5, and once we find it, we're going to put it inside h. So h of something, and that something is j of 5. j of 5 is 2 times 5. 2 times 5 is 10. Now we find h of 10. We take 10 and put it into h. We get the square root of 10 minus 1, which is the square root of 9, or 3. So h of j of 5 equals 3. So what if we aren't given an actual value to put into the function? We just need to find h of j of x. H of j. So we're going to take j and put it inside h. What is the domain of j? The domain of j is all real numbers. That's our input function. We found the domain. Now let's find the composition. We're going to put j inside h, so we write down h without the x. And instead of the x, we put j, which is 3x. So we get the square root of 3x plus 3. So this is going to be the composition. What is the domain of this composition? Well, it's under a square root, so 3x plus 3 must be greater than or equal to 0. Move the 3 over, so we get 3x is greater than or equal to negative 3. Divide by 3, x is greater than or equal to negative 1. Compose or find the intersection of this domain and this domain. Since this one includes everything and this one is limited from negative 1 to infinity, our domain is going to be negative 1 to infinity. And of course you could write that in interval notation as well. Negative 1 to infinity.